So the last section in 8 that we have to do is 8.3. We didn't get that done before. And this does eventually use systems, but let's start off with... So here's the idea. Somebody help me out here. I'm going to overanalyze the hell out of a real simple inequality problem, just to make the connections with the more complicated inequality problem. You guys with me? So don't freak out when you're like, this is an easy problem. What the shit is he doing this? So, for example, x greater than or equal to -1. How would I graph that? What do I make to start graphing this?
A line.
Just a line. Why just one line? Because there's only one letter. There's only one variable. Only need one direction of movement. So if I had a y in here also somewhere, I would need, of course, the whole plane, the xy plane. You guys with me? We don't have that yet. We don't have to worry about this shit yet. So I make a line, number line, because I only got x. And now what do I graph on that line?
Number.
Beautiful. Which one specifically?
-1.
-1. I like it. So why is -1 important? It's a really weird question, I know, but
It shows the limitations.
on one side of -1 will be the answers. And on the other side of -1 will be the not answers, right? Like Giants fans, Jets fans, whatever, right? So greater than or equal to -1, so one of these sides is going to be the answers. So watch what I could do. I could pick 2. Is 2 bigger than or equal to -1?
Yeah.
Yes. So I'm going to shade that way. Now, of course, we're all like, Jeff, you would shade that way. Because that's what the arrow tells me to do, shade that way, right? But I could also think of it as, let me see if something works. If something works on this side, everything's got to work on that side. Because what does -1 do again? It cuts it into good and evil. I mean, answers and not answers, right? All right. I told you I was going to overanalyze a really simple problem. Now, what symbol do I put here? A bracket. Of course, that bracket took the place of the closed circle, right? And then I shade the side of that. So -1 is a point that cuts the x-axis line in half. One side is answers, one side is not. How are we doing so far? My point of this is not to make inequality seem harder, right? You could do this the same way you always did. You don't have to overanalyze it. But now, since we overanalyze this, I can look at something like this. So x makes a line, the number line, and then that number cuts that thing in half. X and y make a plane. Now, how do I cut a plane in half? And I don't mean, cutting a plane in half with that water jet, just to see what it looks like. You guys ever seen the cross sections? No. Okay. How do I cut a plane in half with a what? So if I have a piece of paper, how do I cut it in half? And I make a line through it, right? A line cuts a plane in half. A point cuts a line in half. A line cuts a plane in half. Are you guys with me? Of course, half is a little weird because it's infinite in both sides, but we got the idea. It's half. So if I graph the plane, give myself a starting place here. What do I know about the line that cuts the stuff in half? Yeah, the y-intercept is -1. The slope is up 1, over 1, up 1, over 1. Now, is that dividing line included? Was this included? Yes, right? So I got to have a distinction. If it wasn't included, I would make it a dotted line. It's sort of like an open circle. But it is included, so I make a solid line. In fact, one of my old students said, if you see a line, you make a line. So, right, so is there an equal sign? I can include the line. So I'm going to make it solid, not dotted. Now, on one side of this line are the answers, and on the other side are the not answers.
So, do you trial and error, or
So real quick, watch. This is relatively unrelated to what we're about to do, but it's sort of related. If x was 3 and y is 7, so the point 3,7, does that point work in this? Is 7 bigger than or equal to 3 minus 1? Is 7 bigger than or equal to 2? Yes. So 3,7 should be in the answer. Let's pick a better point to work with. The best point in the world to work with is 0, 0, because it makes the thing easy when I plug it in. So we're going to use what's called a test point. Sort of like what I did over here. I said 2. Does 2 work? Yes. So that's where all the answers are. So if 0, 0 works, all the answers are on this side. All the points above the line would work. If that doesn't work, this must be the not answer side. All the answers would be the other way. And I would shade down. So seeing if this point works or doesn't tells me what side of the line to shade. Just like over here, what side of the point to shade. Let me stop. Yes?
Wouldn't it still be simple because you just follow the arrow? But I get it if it was like...
Yeah, the reason, now personally what I do is, where are the y's bigger than this line? Up, right? But when this gets really steep, up and down, it's less up and down, more left and right, people get confused. So I like to start with a test point, and then I bring that up. Because that's the way I do it. I just go, greater than, up, done, next. But then up gets a little weird when this thing is steep, right? It's like, what the hell's up from this? Ah, shit. It's a little weird. So let's try it. If I plug 0, 0 in, so the test point is 0, 0. If I plug that in, is it true? Is 0 bigger than or equal to 0 minus 1? Is 0 bigger than or equal to negative 1? Is that true? Yes. That is true. I love it when people start saying that, like, this is false or something. This is true. That worked. So this whole side must be where the answers are. Because what's the idea? This cuts it in half. One side is all things that don't work, and the other side is all things that do work. So if that one point works, that means everything on that side works. So that's the answer. You shade up. Every point up here works. So if I try this point, what point is this? 2, 0. If I put that point in, what should happen? It shouldn't work. So if I put a 2 there and a 0, is 0 bigger than or equal to 2 minus 1? Is 0 bigger than or equal to 1?
No.
Is 0 bigger than 1? No. So it makes sense. That didn't work. It's on the not work side. So does it really matter what point you use? No. You just need a point on this side or that side to tell. But 0, 0 is the easiest one to use because it just kills the x and the y. It just makes it real quick to look at. Yes?
The first one when you did 0 is greater than or equal to negative 1. Wouldn't it be wrong because it's not also equal?
No, you don't have to be. What? Say again. Tell me what that symbol means.
Greater than or equal.
Or. There. You have to be greater than or.
Okay, so as long as
And
it's
0 is
minus-
greater than negative 1, so it's definitely greater or equal. Yeah. If I said you have to be less than or equal to 12 years old to eat off the kids' menu at Denny's, right? You don't have to be both, because that would be really hard to do.
Okay.
I'm 11 and 12. He's like, what are you doing, kid? I'm sorry.
Yeah, you can see my final form.
Yes.
Okay, so I get the point of the plotting the x and the y, but how'd you get the 1 and 1? The 1 and 1. Did you just put 1 over x?
The 1 and 1? Oh, well, that is a 1, right?
Right. So
Why did I put 1 over 1? Because that's also 1, because it's slope, rise over run. That's all.
And
If it's a whole number, you can always put it over 1. So you can see rise and run.
But you couldn't do that with the y, it wouldn't make sense?
Because slope doesn't go here. Slope is
okay.
mx, right?
Oh, yeah,
Yeah,
okay. Okay.
That's the only work you have to show is just the graph for these type of problems.
Yeah, and then if you use a test point, you got to show me that.
Oh,
If you
okay.
do the by sight, if that made sense, it's greater. So where are the y's bigger than this? Up. That's why you shade up. That's the quick way to just look at this. But again, like I said, when it gets really steep, it gets weird. Okay, let's try another one. So really, all you need to be able to do this is graph a line. If you can't graph a line, that's a problem. And then plug a point into it. That's the two things you need to be able to do, right? Not difficult. So how about, let's do one more together, and then I'll give you a few to try on your own. Ooh. Sure. So what's kind of wrong about this one?
The X and the Y on the same side?
Yeah, what do I have to do with this to get it to go like what we did over there? Isolate the Y. I love it. I could find the intercepts, but then you could do this that way, but I'm trying to force you guys to get more used to slope and y-intercept because that's a little more important. So if I subtract 2x, right. Sometimes you guys, that just kind of goes over there. You need to write down for yourself what the hell you're doing so you don't make that kind of mistake. It just kind of floats over. You can't do that shit. And then I do what? Divide by 5. So your y less than negative 2/5 x plus 2. So tell me something about that line. Yeah, the y-intercept is 2. And the slope tells me to down 2. And notice if the 2 is negative, the 5 has to be positive. Some of you guys put a negative there and a negative there, but if there were 2 negatives in this should have been a positive number. It ain't. So if you go down 2, you better go positive 5. There's only one negative in this thing. So down 2. 1, 2, 3, 4, 5. Or you could go up 2, back 5. See, that's the same line? As long as one of them are negative. What kind of line will it be? Who remembers what that discussion was earlier?
It's going to be a dotted line?
Dotted line, just like an open circle. You're not allowed to include the points on the line. The points on the line are where y equals this, but it's not allowed to equal. It has to be less than. So this is going to be a dotted line. And now you can either just say less than, so I'm going to say down. Or you can put 0, 0. Is 0 less than 2?
Yes.
So if I use a test point, 0, 0, that'll be 0 less than 0 plus 2. 0 less than 2, yes. That worked. Therefore, I shade down. Yes, sir.
And if the denominator was negative, would that just make the top negative and the bottom positive?
So if the fraction is negative, math doesn't give a shit where you put the negatives, right?
Okay.
As long as you use one of them. So I can either go down 2 over 5, or I can go up 2, back 5. Because math says those are the same numbers. Slope says, that tells me to go back to my house or back, If I get somewhere, I better be able to get back to my freaking house, right? I mean, that's all this is saying. You leave your house, you can get back to your house. Yay. Go down 2 over 5, and I go up 2, back 5. Yay, I'm back in my house.
Oh, okay.
Yeah. That's why you have to be able to go both ways, because the line goes 2 directions. How are we doing? You guys all right? Some of you still need to believe in the power of caffeine. Since that worked, that does work, that point's an answer, that must mean this whole side is full of answers. So if I use this point, it should work. If I use that point, it should not work. So the less confident you are, the more points you can pick just to make sure you got this thing right. How we doing? You just need one test point though, really. Any more would just be another check. All right, you guys try this one. My God. Let's see. Yeah. Okay, I like that.
Yep.
So the blue grade is the grade. You can make corrections on that. Do the day the next test.
Okay.
Yep.
Thank you.
Is everybody okay with the lights being a little dim like this? I like this better. It's a little harsh with all in one.
Not all one? Oh my gosh.
So add 2x and then divide by 3. So why is it negative? Yeah. So I agree with that being negative. There you go. So now you can go up to 3. Yeah. Yeah. Yeah, you could put the negative on the top, which would mean down to over 5, or you can put it on the bottom, which means up to back 5. Because either way, if I go down to over 5 or up to back 5, I'm still in the same line. So when you solve this for y, you should be getting this. And the graphing that line should be easy.
It would be false, right?
For the test point?
Yeah.
We'll see. Yeah, if you plug in 0, 0, 0 is not less than negative. So what do you know about the line?
Goes down.
What goes down? What do you mean?
You shade downward, right?
Oh, all right. Let's get the line drawn first.
So the y-intercept
What do you know about the line? The y-intercept is
-3.
0, -3. And from there I go
Up to over 3.
up 2 over 3. What kind of line will it be? Solid. I see a line, so I make a line. And then 0, 0 is 0 less than 0 minus 3. Is 0 less than -3? No. So that did not work, so I must shade the other way. So every point on that side works. Yes, sir.
And if we divide it by a negative, we switch the signs, right?
Yep.
Okay.
Yeah, so anytime you have an inequality that you divide or multiply by negative, I don't care what the problem is, inequalities have that nature. They
Okay.
say if you divide or multiply us by negative, you got to flip our sign.
Oh.
Yeah.
So even like,
No matter what kind of problem it is, no matter where it came from, no matter what you did before.
so you flip it even if it's multiplication as well?
Yeah, because multiplication is division,
Okay.
right? So remember I told you if you multiply or divide by negative, you change the side of 0 the number's on, so the bigger one becomes a smaller one, the smaller one becomes a bigger one. That's why the sign flips, that's it. It's how numbers work, so it's how variables work, because they are numbers. Is that cool? Now we're about to get into a point, as always, whenever we learn something new, you guys are sitting there going, all right, it's a whole bunch of new shit I got to learn rules for that has nothing to do with the real world. No, you're so wrong. If I had a situation where I was putting some electricity into something, and if I put too much in, this would be a problem. Or if what else could there be? If I had too long of a thing, that would be a problem because you'd lose too much or whatever. So you have all these restrictions. We're about to do more than one line with shading. And the reason we do that is if one thing said I had to be bigger than this line, and another thing said I had to be less than this line, and another thing said I had to be less than that, this is my safe area. That is where people don't blow up. So this shit is used in the real world. right? So if that's when you get something that goes out of here, some little indicator is going to turn red, right? And then you jump off your ass and you go, okay, better turn that off before things blow up or Godzilla shows up, whatever.
Did
Right.
you ever see the movie Disturbia? With Shia LaBeouf, how he tests like with his ankle bracelet?
Oh, I didn't see Disturbia. That's back when Shia didn't go crazy?
Yeah, and he like was testing the perimeter around his yard when he was on house arrest with his ankle bracelet, and he put like.
I love that
things up.
movie.
I
There you
love
go.
that movie.
There you go. So that's perfect. They set up a safe zone where he wouldn't have people come out to
No,
get
so
him.
he knew he couldn't
So he
get
was just
out.
trying to see how far he could go before it.
Went off.
Okay. I like it. I did see it. Okay. So that's a good example if you saw the movie. So let's try one of those. Let's try one that didn't have that much going on yet.
But the homework is gonna have that much going on with 3 lines.
At the very end, you might have 1 or 2 problems. I'm not going to focus on that.
Gotta prepare for the homework.
I want you guys to realize, is it safe to say this is relatively simple?
Yes.
Unless you don't know how to graph a line, which is a problem. That's a problem, period. You
Yeah,
should
but
know how to
when
graph a
you
line.
get to the test, it's like this on steroids.
No.
It felt like this on steroids.
Well, of course it did, because you had no safety net. But to be honest, every problem on that test was related to problems in the homework, or problems
But
we
yeah,
talked
it was
about.
related, but it was just like master problems.
Right, right.
Aw. Okay. So here's something with a system of inequality. Yeah. So this would be something like this. What you got, Jeff? Let's just go straight to the chase here. So if I have a system of equations, I can graph both lines and see where they meet. That would be the answer. System of inequalities, I graph one of the lines in shade, graph the other line in shade. Where the shading overlaps is the answer. So you want to make that part darker to show me that's the answer. Right. So let's try this out. Can you guys just do that first problem? Just by itself, do that first problem. It's just like one of those, right? Same exact thing. Just do that problem all the way out. Get it all the way to where it's shaded. Yeah.
On the day of the test, would you actually have space for gridding
Do what again?
to grid the line?
Oh, yeah. Normally, did I do that on this one too? No? I can't remember. There was something you had to graph. Normally, there's something you have to graph. I do put a little graph thing there.
Oh.
Yeah.
I think some people don't.
Yeah, I know. You should invest in some graph paper, especially if you're anywhere near as bad writing as I am. You should invest in graph paper. Okay, so let me catch up to you guys on this first one. That's so exciting. That's why. For this first one, the y-intercept is 0, 1. And the slope tells me to go
Down 3 over 4.
good. Down 3, 1, 2, 3, over 4. Pop. Or up 3, back 4, same line. What kind of line is this one going to be?
Solid.
Solid. Oh, crap and a half. Oh, crap and a half. There you go. If you don't quite make it, just make the points bigger. This is why it's also good to invest in, or at least look for a straight edge. Now, which way do I shade? How do I tell where to shade? Some of you guys might get the point about greater than, so I'm going to shade up. If I put 0, 0 in, does it work? Is 0 bigger than equal to 0 plus 1? Is 0 bigger than 1? No. That didn't work, so I shade this way. Notice I don't really shade because when you have multiple lines with shading, that's going to get like spaghetti. You just gotta put those arrows. Now on top of that, do this one. On top of that one, do this one. So if you can do one problem, you should be able to do two of them, just on the same graph. Oh yeah, so 5 looks good, and then which way to shade? Yeah, down from it. I like it. All right. So then this guy, the y-intercept is -4. The slope tells me to go up 2/5. And then what kind of line is it going to be?
Dotted.
Dotted. Make it bigger. And then I shade down, or is 0 less than -4? No, so I shade away. So where's the answer going to be? Right in there. Now, of course, it keeps growing that way. The answer's there because that's where the shading overlaps. That's where both inequalities work. So in the real life, this would be my safe area. If I was here, I don't want to be there. Something bad could happen.
So it's no longer above anymore, like that.
Yeah, that only works in one of them. This says both of these have to work at the same time. This is like the weight on an elevator, the number of people on the elevator so people don't suffocate. So you have a safe area to operate in. Yes?
So who wants to actually shade out that part in to signify that's our final answer?
Yes.
Okay.
Please.
Do
Some
you
people-
need the arrows to signal that you know that goes up and that goes down if you're doing two lines, or can you just shade in the correct
This is
spot?
sort of showing me work, but to be honest, some people like to do both lines, and then you have, now let me say this. If you don't understand it, just do it the way we did. Then you have 1, 2, 3, 4 regions, and you can actually pick points from all until you get one that works in both. To me, that just takes longer, so, but it's still valid. So then you wouldn't have to show me this, you're just going straight to the one that works. Yeah. Okay. So that's 8-3. Let me do one last weird one. There's always got to be a weird one somewhere. Now, how are we doing any of these? Aren't we pretending like this is an equals first and graphing a line? Pretend this is an equals first, graph the line. Isn't that what we're doing? Yes? Yes, because that's what we're doing. So yes. So here, how do you graph y equals 1? What kind of line would that be? So think about it this way. Y has to be 1. Y cannot change, so I must stay at the same level.
Yeah,
I can't go up or down because then y would change. So y equal to 1 would be this line, and it's solid because it's allowed to equal it, right? Where the y is bigger than that, now this one you don't have to do a test point. Where, right? Where the y is bigger than that, up from there. How do you graph x equal 2? What kind of line would that be? Straight up and down. If x has to stay the same number, it can't move left or right. It can only go up and down. In fact, think about it this way. Y has to be 1, but what does this first guy say about x? Not a damn thing. So what can x do? Anything it wants to. So look, can't x be any shit it wants to be? As long as y stays at 1. Now x has to stay at 2, and y can do anything it wants to, and what kind of line will it be?
Dotted.
Dotted. And less than, where the x is less than that,
Left.
Yeah.
Yeah, sorry.
So where's my area now? It's going to be this rectangular region up here. That's where they're both true. That's where all the y's are bigger than 1 and the x's are less than 2. That's where that's true. So this is where you only have one variable in the problem, but that means it's going to be a vertical or a horizontal line.
So is that why you went down and made a line across, because everything from -1 up?
From 1, yeah.
Yeah.
From 1.
Oh, that was, okay.
Yeah, so at 1, so y's got to be 1, so this is y equals 1.
Oh, okay.
And it's solid because it's allowed to equal it. This is x equals 2, it's dotted because it's not allowed to equal it, right? Up because it's greater, down because it's less than.
It's kind of like making the graph move over in a sense, or like making a whole new graph on top of that original graph. You know?
Yes. Same thing as this, it's just these are special cases. They're not diagonal lines, they are horizontal or vertical. I like it. Is that, you guys remember that?
Bless you.
Bless you. Okay. So any questions on that stuff? That stuff should seem relatively simple compared to some other stuff you've done.
Yeah.
Unless you can't graph, which again is bad.
Really chill section.
Yes, it should be. Should be. Let's see, what time is it? Let's do a little bit more, then we'll take a break. So let me do a quick little review. We sort of reviewed this before, but just to get us back into the groove. What I like about keeping this until now and not doing it before is we're about to get into systems of equations. So this is system of inequalities. We're actually going to go back in time and go a little bit easier, systems of equations. The bad part is we're going to do systems of equations with 3 variables. Yeah. Why not? So,
This is 9 now, chapter 9.
yes. So I'm going to sort of quickly go through the graphical and the 2 algebraic ways to solve systems of equations. Does it make sense that if there are 2 things I don't know, I need 2 pieces of information to figure them out? Right? So for example, if I told you that I am twice as old as you are, which more than likely is at least that, right? If I said I'm twice as old as you are, can anybody tell me exactly how old either one of us is? That's not enough information, right? So if I said I am twice as old as he is, right? And then I also said that when you add our ages together, you get 65. Can you solve this now?
Yes.
Yes, totally. Now let me show you all the different ways to solve this, right? The most basic way is to graph it, and the reason we go away quickly from graphing is because, for example, this is going to have an ugly y-intercept, right? You with me? But I could graph y equals 2x, which looks like that, and then I can graph y equals negative x plus 65, right? And then wherever those lines meet would be the answer. I mean, that's the graphical method, is to see one line. And again, I don't know if I've said this yet this semester, but when I first teach people graphing, the main, definitely not the only, but the main reason we graph functions, or anything, is to have a quick answer to what are the answers to this. Because how many answers are there to this? More than that. A lot to the a lot power to the a lot power to the lot power is nowhere near it. There's an infinite freaking number of answers, right? So if somebody said, what are the answers to this? I'm start listing them. I'm like, no, let me graph. But I don't want the answer for that. Then just keep following my line. Leave me alone. Done. Next. Right? So it's a graphical representation of all the answers to that equation. That is the most fundamental reason why we graph shit. Is that the only reason? Oh, hell no. Right? So if I graph both of these, the graph of this has all the points that work for this. The graph of this has all the points that work for this. So where's the thing that works in both? Where they freaking meet. That only makes sense. Where they meet works in both. Now somebody give me an algebraic way to solve this, because I don't want to graph.
You plug in the 2x.
Yes. So you could use substitution method.
I was literally doing that.
Substitution kicks so much ass because I know y is 2x. It says it. It says it right there. Y is 2x. So then I can plug that in here. It's sort of like if somebody, so this, I feel a lot like this is solving a murder, right? A murder. Somebody's dead, and I think you did it. And you're like, well, I was with him. That's not good enough, because maybe you both did it. And then he has an alibi that he was at, his friend's house, and it checks out. And I'm like, so if I put you with him together with him at his friend's house, that's evidence that you didn't do it. So I can use one piece of information with the other piece of information directly to get something. So what I'm saying is, if I know y is 2x, how can I rewrite the second equation to be better? I can rewrite this as x plus, well, what's y?
2x.
Freaking 2x. Right? I like it. So your 3x is 65 divided by 3. This is not going to go in evenly, but too bad for us. We're going to be like some little, so it'll be 21 and 2/3. Yeah. I'm 21 2/3 years old. It's like, what the hell? All right. And then to finish this, how would I figure out what y is?
Plug in the 2x.
Yeah, just plug that in, right? So y is twice this. So y is 42 4/3, which is 43 1/3. I don't want to make this into a fraction problem, but that's the basic idea of how to do substitution, right? I like it. Let's just get over the fractions for a second. That should sound familiar. We've done some of that before. And then what's the other algebraic way to do this? Elimination. Just a word banana. So elimination says, if I take the 2x and subtract it from that side, now I've got these kind of lining up here, right? I want to add those together, but only if a variable actually will die when I do that. So substitution is very subversive. It goes in and replaces. It says, okay, why? Let's replace that with 2x. That's why I always think about invasion of the body snatchers for this shit. Let's replace Sam with alien Sam. And you replace it, and then you can solve, because now you only have one variable. Elimination is very in your face. Kill the variable, right? If I wanted to kill the y, why won't they die right now, of course, when I add them? Because they're both positive. So how do I make the y die? Multiply one of them by negative. So if I take that first one, and I multiply it by a -1, please understand, that's the one place I'm using times as an x, right? So that's times -1. What do you get when you multiply that by -1? 2x minus y equals 0. So now if you add these together, that should look very familiar. Especially if, that didn't look like Egyptian hieroglyphics, yes.
Why in elimination you only multiply -1 to the y and not to the x as well?
I totally did. Because what was it? Negative. Now it's positive. I changed the sign, right? And multiply by negative. What's -2 times -1? Positive 2. What's y times -1? Negative y. And of course 0 stays 0.
You didn't add the two equations together? Like that made a
Totally did. But why would I use him? I use the improved him.
Oh, okay.
There's the first equation written in a better way. And there's the second equation. Why is this a better way? Because now the y's die when I add them together.
Okay, I gotcha.
So don't say I didn't use him, because he's right there. So if I just change into a suit, right, you wouldn't go, well, where's Jeff? For shit. Somebody might go, I don't know who you are. You're Jeff. I don't know if he owns a suit, but I do own one suit. And then you can and see how you get the same place, right? I don't have to finish that shit out because that's exactly where we were before. You get the same thing if you solved it. Blah, 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 blah. This is a quick review. This is stuff you should know already. Yes?
When you graphed it for the x plus 2y, did you isolate the x or did you isolate the y? Graph.
Well, I mean, y equals 2x, so the intercept is 0, 0, up 2 over 1. And x plus y equals 65, it would have a y-intercept is 65, and it would go down 1 over 1. I didn't feel like doing that.
Okay.
But if you did have something you could graph it and just see where they meet, that would be the answer, done. But this, I don't want to graph it, so that's why I want there to be algebraic ways to do it.
Oh, okay.
I like it. Notice this. X equals 1, if I graph that, what's it look like? A point, right? So a single variable defines a point. A single variable equation defines a point. Two variables in an equation defines a line. So we're about to take this step into three variables. Three variables in an equation should define a parabola. So when you put a bunch of points together, what do you get? A line. If I put a bunch of lines together, what do I get? A plane. You got me? You with me? Oh, shit. So, two variable systems of equations. I can graph one line, graph the other line, and the answer is where they meet. Three variable systems of equations we're not going to do graphically because you have to graph a plane and another plane and another plane and see where they meet. But there is an example of this in this room right now. This kicks ass. This wall is a plane. Right? You with me? So if I had an equation that defined this wall, and I had an equation that defined the ceiling, and I had an equation that defined that wall, shit, can't really see it, but where would the answer be to that system of equations? This wall, the ceiling, and that wall. At the corner, at the point that you guys just understand is there. Right, if I did the back wall on that one, it's going to be that point in the corner, right? There's a point where they meet. Now, do two lines have to always meet? So you could have a situation where there's no solution. What if they were actually on top of each other? If the answer is where they meet, then the answer for this is all the points on the line. So two planes don't have to touch each other, right? Two planes could be like this, right? Which is why you want normal planes, is just to not hit each other, right? You with me? Yes. And then once you bring in another plane, they could do all kinds of weird shit. So when I have systems of three equations, there actually are more ways for there to be no solution than normal. Because to get three planes to line up to one point takes quite a bit of work, right? Thankfully, most of our answers are going to not be no solution. They'll go crazy, like the factoring, go prime, 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 prime. They'll go no solution, no solution. No, 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 no. Right? Most of them are going to have a solution. Yes?
So in what case would it be no solution then?
We'll see what it looks like.
Okay.
Like, for example, with this, when I try to solve it, I would get 0 equals 1.
Mm-hmm.
That tells me there's no solution. Does that make sense? Here, I got x equal to, there's an answer when x is 21 2/3, and then I can figure out what y is. But if here I solved it and I got 0 equals 1, that's saying there's an answer when 0 equals 1. Oh, math. That's a weird-ass way of saying there's no freaking answer, right? So we'll get something like 0 equals 1, or 7 equals 2, or negative 18 equals 5. Something that's not true that's saying there's no answer.
When pigs fly.
Sure. All right. Let me ask you. Do you want to take a break now, or maybe now is a good time to take a break?
Yeah.
Because that was a nice overview of this shit. And before we get into the three variables, let's take a break. Let's see. Come back at 49:40.